Hey everyone, welcome back to Aryan's Bytebeat Academy. I am Aryan, and today we are diving into one of the most crucial concepts in software development, the solid principles. Whether you are a beginner or an experienced developer, understanding solid principles is going to take your coding skills to next level. These principles are foundation of writing clean, maintainable and scalable code. And once you get the hang of them, your approach to software design will change forever. So make sure to stick with me until the end of this video, because not only will I break down each principles in detail, but I will also show you practical examples so you can apply them in right way in your project. So now let's start. So the first thing is that what are solid principles? In software engineering, SOLID is a mnemonic acronym for 5 design principles intended to make software design more understandable, flexible and maintainable. Solid principles, if we give it in a full form, so where every word out of 5 has its extended form. So like we have S for single responsibility principle, we have O for open close principle, then we have L, that is Liskov Substitution principle, then we have I, it is for interface segregation principle, and then finally we have D, that is for dependency inversion principle. So these are the extended forms of terms solid, where every particular word has its extended form, like S single responsibility, O open close principles, L for Liskov substitution, and I for interface segregation. And in the similar way, D stands for dependency inversions. So these 5 words are used to explain the concepts of solid principles. So let's proceed. Why we should use these? Now the question is that in our mind, why we should use solid principles? Without using solid principle, can we not write the code without using the solid principle? We can write, but solid principles has given their own advantages. So what those advantages are? Let's discuss them one by one. Let's discuss the advantages of using solid principles and how they are helping us to make our code base more scalable. So the first one is enhanced maintainability. So by promoting clear and organized code structures, solid principles make it easier to update and maintain software over time. This reduces the risk of introducing bugs during modification. Then we have got improved code readability. So what does it actually mean? Code adhering to solid principles is generally more understandable. This clarity helps new developers quickly grasp the project. Quickly grasp the project means when someone new joining our company or organization, and when this code is handed over to him, he can easily adapt it with it. And because the code is quite clean, and facilitating collaboration and onboarding. Then we have got the third advantage, what? Increased flexibility. So following solid principles allow for easier changes to software, such as adding new features or making adjustment without impacting other parts of the system. Then we have got better testability. So solid principles encourage modular code. Modular means we have different parts of the code, we can say, like we have one module for fetching the data from the API, and we have different module of database, and we have a different module for printing. So module, it provides the concept of modules, which simplifies testing. Each component can be tested independently, leading to more reliable and robust software. Then the fifth one is promotes reusability. So adhering to solid principles often results in components that are reusable across different projects. Yeah, we are following the concept of modularity. We are writing our code in modules, so that modules are reusable. Like if that data fetch module or that data retrieval module from API is required to be used in some other project, so we can easily migrate that. So this reduces redundancy and accelerates development process and saves the time for us. So now you must have an idea, what is the crucial role of solid principles. So if we are following these best practices in our code base, these are definitely improving our code and making it more scalable, reusable and more readable. So let's proceed now. Single responsibility principle, the first one. What actually this single responsibility principle is? The single responsibility principle states that every class should have one and only one responsibility. Or in other words, if there is a need to change the class for more than one region, then that defies the single responsibility principles. Yes, for example, if we have a database class that is responsible for database operations, then it should be used only for database operations. And if we have a print class, then it should be used for printing related tasks only. It should not happen like that. We are writing printing code in database class, or we are writing database code operation class in print. So that will be a bad practice. So in other words, we can say it like a class should have a single region to make changes in it. Like if I want to make change in the printing functionality, so that print class is having single region, that there is some requirements to be made in print functionality, then print class can be changed. And like in a similar way for database class, if we want to modify something related to database connection, then we should use the database class to make change. It should not happen that like we want to change the printing functionality and we are working in the database class, and we want to change the database functionality and we are working in the printing class, and if we want to change the printing functionality then we are working in the database class, or vice versa. So it should not be happening. So let's see how practically we can achieve this. Like here is one incorrect implementation of single responsibility principle. Here we have a data class that has 3 variable, ID, name and password, and this class is also having 2 methods, sign in and sign out. So basically we can say this class is managing user data and also sign in and sign out process. Now let's assume that we need to make some changes for the authentication process. Like the sign in and sign out process are being used for authentication purpose, and I want to implement the OTP feature also. So now what I would do, I would make change in this class. I would add a function here like send OTP, and if I have got another requirement to get the user's address also, so then I will be making the change in the user, adding a variable here. So now this class has 2 regions to change, one for authentication purpose and another for getting the attributes of the user. So when such scenario occurs, we should separate our classes. This means the user class should only have one responsibility to hold user information, and there should be one more class that's like authentication service, and that should be responsible only for authentication services. So what will be the correct implementation? Like we have split the classes, we have made 2 classes now. one is data class and one is authentication service class. So now if I want to add a variable for a user like address variable, I can make change in this. If I want to add one more variable like date of birth, I can make change in this class, but this will not be affected. Like this authentication service class will not be affected by the user class changes. And in the similar way, if I want to add OTP functionality, like I want to write a send OTP function, so I can write that here. So now this has only one region to change related to authentication service, and this has one region to change only related to user information. So this way we are achieving single responsibility principle, means here are both the classes are having one region to change, authentication service for authentication related task and user class for user information purpose. So I hope you must have understood this single principle, single responsibility principle. Now let's proceed. Then we have open close principles. So what does this open close principle means? Open, this means that we can add new features to our classes. When there is a new requirement, we should be able to add new features to our classes easily. But at the same time, what does close means? This means that the base feature of the class should not be changed. Yes, that is the open close principle. Like now take an example, like you bought a car, new car, and you want to add some accessories in that car. So it means you are not modifying the basic feature of the car, that is driving on the road, but we are adding certain things to that, we are adding certain accessory. So open close principle says the same thing. The base feature of the class should not be modified, but it is open for extensions. Like in the car we can get accessories added, but it is not like that we are making it not runnable. So if that is not runnable, means that is not a car. So in the similar way, the base functionality should not be changed of a class, but we can add something to that class. So this is open close principle. Let's take a code example of it, how the open close principle works. Like we have an incorrect implementation here. Here you can see you have a class rectangle and a class circle, and we have a class named area factory which calculates the area of shape. Having a close look at the code, we see that we have an if else statement to separate out the shapes. Yes, here we have the if else statements. Okay, now and as the shapes increases, they will continue to grow that way, because the class is not closed for modification. Like if I added here one more class like triangle, then I have to add here one else clause. If I added one more class here square, then I have to add square, one more else case for square. So now this class is actually not closed for modification, but it should be closed for modifications. So because the class is not closed for the modification and neither it is open for extensions, hence it is violating open close principles. How will we fix this? So we will fix this with the help of an interface. So what will be the correct implementation? We created one interface shape here, and that's having the get area method. Then we created method rectangle that is implementing this shape interface. Then we have got a circle class that is again implementing this shape interface, and we have got a area factory class. Now in this area factory class we have removed that if else part. So we have written a function that will accept array of the shapes, and it will calculate the area of that particular shape. So if we pass the two class rectangle and circle, it will work for that. And if I added one more class like triangle here or square here, then we simply need to add those values to this calling array, calculate area array, and this class will not require any change to be made. I think it should be clear to you all. Let me take you one more time to this. We have created one interface, that is get area, then there is a rectangle class and there is circle class. But what change I have made in the area factory class is that now this area factory class is having a function that is accepting shapes as in an argument as an array. So now in this array we can pass n number of classes from here and it will not require any change. So the base functionality is calculation of the area, so that is not being changed at all. Now because we can pass rectangle, circle, we can add 2 more classes like a square or triangle, but this code will not be changed and this will be working for our code base. So that is the open close relation, open close principle, basically that is open close. So that is the open close principle of the solid principles. Now we have got the third one. So now we have got the Liskov substitution principle, and what does the Liskov substitution principle say? The child class must be substitutable for the parent class. Since child class is extended for parent classes, they inherit their behavior. So we should be able to use subclasses instead of the parent classes, which class they have extended, without the need to make any changes in our code. If child classes cannot perform the behaviors belonging to the parent classes, probably we will not write any code in the method that does the behavior, or we will throw an error when objects want to use it. But these actions cause code pollution and unnecessary code crowds. So let's see some practical example of this also, how we can implement practically the Liskov substitution principle. Here you can see in the incorrect implementation we have got one abstract class, that's vehicle, and it has some maintain like is engine working, false, start engine, stop engine, move forward and move back. So we have a car class now. So we have a car class now, and so we have a car class now, and that car class is extending this vehicle abstract class, and it is using the start engine, stop engine, move forward and move back method. So till this point there is no problem in this code, but the problems occurs now. Like we have got a bicycle class. Now this bicycle class is also extending the vehicle class, and this move forward and move back method is fine because class bicycle has this behavior, but start engine and stop engine, these methods are not required to this bicycle class. These methods are required in this car class, but these methods are not required in the bicycle class. So that is the problem. Now how we can solve this problem, that's what Liskov substitution says. So how would you solve this problem? Like we will create a interface. We created one interface and we put this move forward and move back method in that vehicle interface. Then we created an abstract class vehicle with engine, and this abstract class is inheriting this vehicle, this abstract class is implementing this vehicle interface, and now it has got this variable is engine working, false, start engine and stop engine. Now car class can use all the methods. It can use move forward, move back, and it can use these 3 methods also. So like you can see, start engine, stop engine, move forward and move back. But this bicycle class now is implementing the vehicle interface, and it is using only 2 methods, move forward and move back. Earlier we saw what it was using some unnecessary methods also, but now it is only using the required methods. So this is what Liskov substitution enables us to do. So now it's time to discuss the interface segregation, the next one. So what is interface segregation principle? This principle states that once an interface becomes too fat, it needs to be split into smaller interfaces so that the client of the interface will only know about the methods that pertain to them. Means here, if you built an interface, you wrote an interface, and that interface is having too many methods, and those methods are not useful for all the clients. So in that case, we need to split that interface in two interfaces, and we should contain only the relevant methods. So in simple terms, we can say this principle says that your interface should not have too much methods. So let's see this in a practical example. So let's see by an example here. So here we have got one interface, that's interface name is animal, and it has got three methods: eat, sleep and fly. Now we have class cat, and that inherits, that extends this, or that implements. Now we have got a class here, the name is cat, and that simply implements this animal interface. So this eat method is required, okay, sleep method is also required, but as this is a cat class and cats do not fly, so this method is not necessary to be implemented by this cat class. Now we have got a bird class that also extends or implements this animal interface, and here we have got eat, okay, that is a usable method. Sleep, that is again a usable method. Fly, this is again a usable method. But on the previous slide we saw this this fly method is actually not required. So what we should do, we should split this interface in two parts basically, and because this interface is now becoming fatty interface. So what will be the correct implementation in that case? So yes, here is the correct implementation. Like we should have one interface, that is here animal, and we can have another interface, that is what, flying animal. So now we have categorized the interfaces. So now this animal interface is having eat and sleep method, and flying animal interface is having fly method, because every animal does not fly. So now if we see, there is a class cat, and that is implementing this interface. So this eat method is usable and sleep method is usable to this cat class. And let's move to next. Then we have got a bird class that is implementing both the interfaces, animal and flying animal, because the bird class needs the fly method also, that's why we are using this flying animal method also. So eat, sleep and fly. So here you saw how we have solved the problems of fatty interface. We split it into two, and now this cat class is cat class. So now this cat class is having only those methods, those are required, and in the simple way the bird class is also having only those methods that are required. So I hope this must also be understood by you. Let's move to the next thing. Then we have the last one. D stands for dependency inversion principle. So what does this dependency inversion principle say? This principle states that high level modules should not depend on low level modules, and both should depend on abstraction, and abstraction should not depend upon details. So here you must be getting confused, what is high level module and what is low level module. So high level module is the module that is using the other modules, and low level modules that are being used. So like in our program, main function is a high level module. So details should not depend upon abstractions. Let's see this by an example here. Here we have the incorrect implementation of dependency inversion. Suppose that we have a class. So let's assume that we need to develop a mobile application for both Android and iOS. To do that, we need an Android developer and an iOS developer. So these classes will have a method to develop a mobile application by using their own platform and programming languages. So here we have got one class that is for Android developer, and it has got a method develop mobile application, and we have got one more class that iOS developer, and that has got its own method. And now this is what we have our main function. So this we can say this is what a high level module. So suppose that if I want to add one more type of developer in this, like a web developer, in that case I have to make changes in this module. You know, whenever a new developer is being added, like for example I added a web developer here, I have already two here, one is the Android developer, one is iOS developer. In that case I have to add that I have to make some changes here in this main module. That's what I do not want to have. So in that case, what is the solution for that? Basically, so to fix this problem, here we can create an interface. An Android developer and iOS developer class will implement this interface. So let's move to the correct implementation. So here what we did, we created one interface, that is mobile developer, and that is having develop mobile app method. Now we have got a class, that's what Android developer, and we have got another class, that's what iOS developer. So these are the two classes we are having here now, and this is having its own methods and this is also having its own methods. Now you can see here this main module has been written in such a way that if I add any type of developer here, like I added a web developer or I added any other kind of developer here, in that case I just needs to put one instance of that developer here, and there is no any other change that we need to make here. And if we delete that developer, then simply we would remove it from here. So this way we have removed the dependency. So what we have done now, there is an interface here, mobile developer, and this Android developer class is implementing this mobile developer interface. We have iOS developer class, and this is also implementing this mobile developer interface. And now we have created an array of what we have created a array list of that developer classes, and we have provided the two Android developer and iOS developer classes. This is what enumeration basically have been created, if you are getting confused from this. And because Android works on different kinds of devices like Huawei mobiles or Google mobile devices, so or even on both devices, so we will pass the type of service. So but that is the different thing, that is not a part of dependency inversion, that's a part of programming logic. So here we are just passing a list, basically this is the list basically passing. So if a new developer is added, like a web developer is added here, so we simply need to add a parameter here, and this for each loop basically will work for us. So we need not to make any other change in that. So I hope this concept will also be clear to you, and this dependency inversion principle, this is how we can optimize our code, how we can make our application scalable, and how we can use the concepts of solid principle that are the industry standards. I hope you now have a solid understanding of the solid principles and why they are so important. These principles are not just theoretical, they help ensure that your code is more flexible, easier to maintain, and can adapt to changes without becoming a tangled mess. If you apply these principles consistently, you will see improvements in both your coding efficiency and the quality of your software architecture. Thanks so much for watching. If you found this video helpful, don't forget to like, share and subscribe to Aryan Bytebeat Academy for more valuable content like this. Let's keep growing as developer together. So see you in the next one. Thank you.